Hi, I'm Seth Rotenberger, and today I will demonstrate and touch on NX's out-of-the-box MBD rules. Model-based definition, or MBD, is the practice of producing a complete digital definition of a product within a 3D model, such as applying a default tolerance, specifying multiple datums, creating size and locating dimensions, and more. The NX MBD rules provides rapid definition and authoring of product manufacturing information, or PMI, with an emphasis on capturing knowledge and company-specific business logic. You can use your choice of the over 100 available production-ready out-of-the-box MBD rules, or when necessary, define your own that complies to your specific business needs. Rules leverage topological feature recognition that also enables support for authoring on multi-CAD data. To demonstrate how simple it is to use and apply these out-of-the-box MBD rules, I have the assembly of a coffee maker loaded in the design space. As I am responsible for the outer casing of the coffee machine, I open the sub-assembly of the outer casing to another window before I add any of the available MBD rules. To add out-of-the-box MBD rules, I simply navigate to where these rules can be accessed via the Reuse library on the resource bar. Each category folder here contains grouped MBD rules ready to use. I expand the folders and navigate to the subfolder MBD Logic Rules. Hovering over the rules listed in the folders shows a tooltip for each MBD rule, so that you understand the result of applying the specific rule. Here we want to execute a common task such as adding a parts list. We can do that by adding a part table, which will show the different components in this assembly in a list, and provide information about them, as well as the automatic labeling of components to the corresponding line in the part table. These are the different part attributes that I would like to see in our part table, and they can be customized to fit your design requirements if specific. Our table has been created, and you can see all the different information that can be found on it. We can see the name, quantity, part number, description, and material of all the components in this assembly. There is an easy way to view each of these components, and to do that, we will use the emphasis function. As you can see, the model is now translucent, and when we select a component, it is easy to distinguish it from the rest of the model. I would like to show you another example of using out-of-the-box MBD rules. Here I have a single part with a large number of simple holes with different dimensions. All of these holes need PMI assigned to them to achieve a complete digital product definition within the 3D model. There are many out-of-the-box rules that can easily be used to fit your application. In this instance, we will use the Create Size on Holes rule. You can see, when moving the cursor over the selectable rules, a tooltip tells you the expected result of the specific rule. Let's now add the Create Size on Holes rule. The tolerance here can be changed for specific parts, but we'll use this one for our application. The PMI created by the MBD rule has the count, diameter, and tolerances of the holes already displayed for us. There are different tolerances for different sized holes, and this is because the rule uses hole size and tolerance tables when creating the PMI. The PMI created by the rule has been created for all of the holes with smart selection and associativity tied to them. For example, the system has identified and associated all the 0.7 mm holes and grouped them together. When selecting the tolerance of the holes, the PMI will highlight and display all holes associated with the specific PMI. Due to a design change, one of the holes is no longer needed, so I can remove it. With the hole deleted, we can see that MBD rules track changes as the PMI tied to the hole changes. The PMI on the 3.2 mm holes have become retained, which signifies that changes have been made and the rule needs updating. There is an integrated intelligence in the rules, and if I go into the MBD Navigator and update the rule we just added, we can see that the quantity of the 3.2 mm holes updates to reflect the actual number of holes in the part. Let's recap what you have seen. You saw me open an assembly and use one of the over 100 out-of-the-box MBD rules. We quickly added a part table in the 3D model to the product definition with the associative part table itself, consisting of the components and selected attributes, as well as the labeling tied to each component. You then saw me toggle on the emphasis view option to more easily locate specified components of the part list in the 3D assembly. The components were selected out of the part table and emphasized in the graphical window. In a single part, I added a rule to display the PMI of the holes in the part. We noted that the MBD rule efficiently and smartly selected, added, and grouped associative PMI information to those holes, with hole size and tolerances for each specific hole. The MBD rule utilized a tolerance lookup table that greatly assisted in defining the use tolerances for each hole, and is based on hole size. This removes the need for manually adding tolerances to each hole. A design change was introduced where a hole was deleted, and the PMI then displayed retained. This calls for the user to validate the change, and the PMI is easily updated as it is defined by an MBD rule. I would like to thank you for your time and attention.